Everyone, I am making this video particularly for the revision of year 10 examination. So what we're going to be doing today is we're going to be talking about the mid-year revision of our O-level chemistry. So we'll be dividing this video into three portions. First, we'll be talking about the revision of chemical bonding. We'll talk about states of matter in the next part, and then we'll divide the third part for some equation writing practice. We'll talk about some equation writing practice. So let's talk about chemical bonding first. We know there are overall three main kinds of bondings: ionic, covalent, and metallic. In ionic bonding, we have metals reacting with nonmetals. In covalent, it's nonmetals combined with other nonmetals. In metallic, it's a pure metal or it's an alloy. By the way, alloys are mixtures of metals, not compounds. So we'll talk about their general properties. Ionic bonds are formed when metals lose electrons, non-metal atoms gain electron, and then there is ionic lattice formed, which is a lattice of positive and negative ions. Covalent bonding happens when non-metal atoms, non-metallic atoms share electrons with each other. Metallic bonding happens where metal atoms form a lattice of positive ions. It's a lattice, which means regular arrangement, a lattice of positive ions with sea of electrons. So that's the description of these three kinds of bondings. Ionic bonding has the properties of high melting point and boiling point, conduct electricity in liquid, which means aqueous solutions or molten. You melt them or you dissolve them in water. The third property is that they are soluble in water mostly. Not all of them, but they are mostly soluble in water. So solubility is not a priority answer to write. When you talk about covalent compounds have two different categories. One is simple covalent, the other is giant covalent. And that is why the properties are differently written. So for simple covalent, the properties include low melting point and boiling point. They do not conduct electricity at all, and they are mostly insoluble. They're mostly insoluble in water, obviously. This is what you're talking about. When you talk about giant covalent structures, I want you to remember the giant covalent structures were diamond, graphite, and silica, which is silicon dioxide. So they have very high melting and boiling point. Graphite conducts electricity because of the mobile electrons, but diamond and silicon dioxide does not. Diamond and silica do not conduct electricity. Do not conduct electricity. And obviously they are insoluble in water. When you talk about metallic structures, they again have high melting point and boiling point. The second thing is They conduct electricity in solid, liquid, both. These are the main properties of these structures. Remember one more thing. Ionic compounds conduct electricity when liquid. Metallic compounds do even when they're solid, even when they're liquid. So this is a basic revision of bonding. Let's quickly run through their dot and cross diagrams for revision. In ionic structure, when you draw dot and cross diagrams, you pick a circle, you make two circles, or you can say two sets of circles with, for example, their entire shells. Let's suppose I'm picking sodium oxide. So you will put proton is equals to 11 for sodium and proton is equals to 8 for oxygen. You will put their electrons using dots for 1. So for example, sodium electrons are written with dots for sodium positive ion, which has a configuration of 2, 8. And for example, for oxygen, you will write the configuration which is 2, 8 because it's not just oxygen, it's oxygen minus 2 ion. And here you will pick crosses. Crosses like 2 crosses in the first shell, 6 crosses in the second shell, and since oxygen is gaining 2 electrons, you show 2 electrons using the dots of sodium. You put square brackets always, you put charges on top of them, and then you put big numbers for balancing them. So since sodium is 1, oxygen is 2 charge, so you put a 2 around sodium. So that is how the dot and cross diagrams of ionic is made. But in the covalent dot and cross, for example, we are picking water as an example, the circles overlap. So you will make 1 oxygen, you will make 2 hydrogens, the hydrogens will be drawn like this, overlapping is there, you will label them like hydrogen, hydrogen, oxygen. Hydrogen makes 1 bond with oxygen, so 1 dot from 1 hydrogen, another dot from another hydrogen. Oxygen will give 1 electron from each side to complete the electron pair. The remaining electrons of oxygen are written outside the overlapping portion. This is how the covalent diagrams are made. You can see there is no overlap in the diagram of ionic structures, but there is overlap in the diagram of covalent structures. With this quick revision, let's go back to the concept of states of matter. I want to go through 2 important topics. First is volume of gases. Second is diffusion. When you talk about volume of gases, there are 2 main laws. One is volume and temperature are directly related. The other is volume and pressure are inversely related. So when temperature increases, particles gain energy. When they gain energy, they overcome their attractive forces, they overcome their attractions between each other and move away. And when obviously they move away, spacing between them increases. Spacing between them increases. So as a result, volume increases. About pressure, you can say when pressure is applied, particles are pushed closer to each other. Particles are pushed closer to each other. and thus spacing decreases. Spacing between them decreases. So this is how the two laws are connected. The volume and temperature are called the Charles law. The volume and pressure relationship is called the Boyle's law. If you remember Brooklyn Nine-Nine, I know what I'm trying to say. In diffusion, we need the definition of diffusion. The definition is random spreading of particles. Do not talk about that higher concentration to lower concentration, because diffusion is random arrangement of particles. Diffusion depends on three things. It depends on molecular mass or atomic mass. It depends on temperature. And the third thing, which is not really important, is the concentration gradient. So just let's talk about molecular mass or atomic mass. As the mass increases, the speed of diffusion decreases. So heavy particles move slow and lighter particles move faster. When you talk about temperature and speed of diffusion is related. The reason is more kinetic energy is available, so particles absorb the energy and move faster. We don't have to talk about the concentration gradient anymore here. So this is a quick revision of the volume of gases in the diffusion portion. Let's quickly go through the concept of formula making and equations. Before that, I'll revise the idea of formula writing. There are two kinds of compounds generally, ionic and covalent. In diionic compounds, there are ions with charges. So metals are positive charges and non-metals are negative charges. The periodic table will tell you the charges. In covalent compounds, there are no charges. There are no charges here. So use the word mono, di, tri, tetra, penta to communicate 1, 2, 3, 4, 5 elements. Let's have an example. Calcium sulfate and sodium nitrate are formed by reacting sodium sulfate and calcium nitrate. We need the formula before we write the equation. We will write the word equation first, and then we will write the chemical formula equation. For word equation, it's very simple. Two things are formed. Whatever is formed is our product. So these two are products because they are formed. And whatever was reacting, by reacting this and this, so they are reactants. So sodium sulfate plus calcium nitrate, arrow, calcium sulfate, and so plus sodium nitrate. The word equation has arrows and like plus signs, but with the spelling or the name of the compound rather than formula. For chemical equation, we know sodium sulfate has a formula Na2SO4. Calcium nitrate has a formula CaNO3 twice. arrow. Calcium sulfate has a formula CaSO4. Sodium nitrate has a formula NaNO3. Now you can notice one thing, there are double NAs on the left side but only single Na on the right side. So you can balance it by putting a big 2 around the sodium nitrate. This way it's balanced. You can see sodiums are twice now, and you can also see the nitrates which were twice on the left side. There were 2 nitrates on the left side. Now there are also 2 nitrates on the right side. Let's go for the second equation. We'll write the word equation first, and then we will write the chemical formula equation. Silicon tetrachloride is added to water, so two things are combined, which are our reactants here, silicon tetrachloride and water, to make what? To make fumes of hydrogen chloride and white precipitates of silicon dioxide. So these are our products, the one blue. Silicon tetrachloride should have a formula of silicon, and tetrachloride means 4 chloride. So silicon, like just one silicon, and tetrachloride plus added to water means H2O, then arrow. This should have been the word equation. So silicon tetrachloride plus water, arrow, hydrogen chloride and silicon dioxide. So silicon dioxide. Word equation is done. Now chemical equation will involve silicon tetrachloride, which is SiCl4. We know water is H2O. Hydrogen chloride is H with Cl. H is plus, Cl is minus. And silicon dioxide is SiO2 because the di means 2. If this equation is not balanced, you can see there are 4 chlorides on the left side but only 1 on the right side. So we can balance this by putting a 4 before HCl. Now you can see there are 2 H's on the right side because of the 4 H's on the right side but only 2 H's on the left side. So they are not balanced. We can balance it by putting a big number 2 before the water. This way the water will become twice. Now you can see the hydrogens on the left side are 2 times 2 is equals to 4, and on the right side it's already 4. So balanced. You notice the chlorides on the left side and you notice the chlorides on the right side, all balanced. So this is how you write balanced chemical equation. Remember, equations always have to be balanced. I hope you guys will do really good tomorrow. Thank you guys.